All right, guys, so today we're talking about 5-number summaries, which when you're analyzing data, it just gives you more information than just having the average. We kind of fall into a habit of thinking that the average is the only number that matters when we're looking at data. And a lot of companies out there would love for you to look at nothing but the average because it doesn't necessarily give you all the good and all the bad of what's actually going on. So another diagram, another thing that we analyze when we are looking at data is the 5-number summary. And you've done this before. The easiest way to display a 5-number summary is with a box and whisker plot. You've got a box here in the middle, and then you've got 2 whiskers coming off the side, which is why it's called a box and whisker plot. But the way this diagram works is at the ends of the whiskers, you have the largest and smallest data value. Okay, so those are 2 of your 5 numbers. In the middle of the box, you have the median of your data, not the average, you have the middle number. And then you have these 2 ends of the box. These are called the first quartile and the third quartile. And these represent kind of like the middle of the top half and the middle of the bottom half, because from this whisker to this median is half the data, and the first quartile is in the middle of that data. From the median to this whisker is the other half of the data, and the third quartile is the number that's in the middle of that upper half of the data. Excuse me. So when you are analyzing information, a lot of times you want to look at things other than the average to give you an idea of where that data is at. Now, a few things that are important about these box and whiskers that you want to make sure. Going across the bottom is what shows you the values. Now, it's really important when you are reading a box and whisker or making one that the distance between those values stays the same. So if this is 10 and this is 15, that means every data point should be 5 apart down here across the bottom. If not, then you have a misrepresentation of the data and you should strongly consider not trusting the data that you're looking at. So that's important that those distances are the same. It doesn't matter what the distance is, but it does matter that it's the same from one point to the next. The other thing that's important to consider is that it doesn't matter how big a whisker or a box is, they all contain 25% of the data. So in this box and whisker on the example, 25% of all the data points are in this big wide box. This skinny box contains just as much data, but that data is closer together, so that box isn't as wide. And same with these whiskers. This whisker is 25% of the data points, as is this whisker at the front. So it's easy to look at these and think, oh, there's a lot more data right here because look at how big that box is. But that's not true. There's just as many numbers in here as in the smaller box, all right? Now, one of the reasons we like box and whiskers is when we are dealing with outliers, the box and whisker plot can help us visualize what's going on. Because when you draw the box and whisker plot, there's 3 different ways it could possibly be shaped. In general, obviously there's some nuances here, but in general, there's 3 different ways that it can be shaped. It can be symmetric, which is an example right here in the middle where the whiskers are about the same length and the median is about in the middle of the box and whisker plot. So the boxes are about the same and the whiskers are about the same. Now, skewed left means that there must have been an outlier to make this whisker on the left a lot longer than the whisker on the right. Or maybe several outliers that made the box on the left bigger than the box on the right. So when you look at this data, when you look at this graph on the left, 50% of the data is in this little tiny area, and the other 50% is spread out along this great big area. We call that skewed left. If the whisker on the left is longer and the box on the left is longer, we call that skewed left. Skewed right means that there are data points to the right that are pulling the data to the right, and those sides of the graph are longer than the left side. So that would be called skewed right. Now, this really can help you understand what the data is doing beyond just an average. It gives you a sense of where the data is concentrated, and how close the data is concentrated to itself and overall. So let's start with making a box and whisker plot. So the easiest way to do this, if you don't have a calculator or you're not doing this in class, you're gonna have to do this at home. There is, on the front page of the homework, there is an example of doing this by hand that will show you how to do it. We're gonna assume that you're doing this in class and you're using my calculators. So what you do is the first thing you're gonna do is hit the data button, and it's gonna ask you to make a list of numbers. And you're gonna type in all those numbers in the list. You're gonna hit 24, enter, 30, enter, 30, enter, 22, enter. You make all of those points in the list. Then you are going to hit the second button, and then you're gonna hit data again, because what you want is the stat, the green stat button. And when you do that, it's going to give you a couple of different options. You want the 1var stats, because it gives you the 5 numbers that you need to draw this diagram. Rather than having to put them in order and count and find the averages and all this different thing, it'll give you the 5 numbers that you need. You need the minimum, the maximum, the median, the first quartile, and the third quartile. This gives you all 5. So when you put in the data set above and you go to 1var stats, hit enter a couple of times, it's gonna give you a lot of information. It's gonna give you the average, it's gonna give you the standard deviation. You're gonna scroll down until you find the minimum. In this case, the minimum is 18. If you keep scrolling down, you'll see Q1. That stands for quartile 1, and in this case, it's 23. Then it gives you the median, 25. You keep scrolling and you'll get quartile 3, which is 29. And then you'll get the maximum, which is 30. So this gives me the numbers that I need to make my chart. So I start by drawing the number line at the bottom and deciding how far apart I'm gonna spread out my tick marks. I'm going from 18 to 30, and I've got a lot of odd numbers in the middle. If I wanted to, I could count every tick mark, but I'm gonna go up by 2. So I'm gonna put 26 in the middle, and then I'm gonna do 28, and then I'm gonna do 30, and then I'm gonna do 32. And going the other direction, I'm gonna do 24, and I'm gonna do 22, and I'm gonna do 20, and I need to make my chart a little bit longer, and I'm gonna do 18 down here at the bottom. Now do your best to make these the same size, right? I'm going up by 2, and it's important that the distance between my tick marks is the same distance. So I want this distance right here to be the same all the way across, and that's kind of hard to do by hand. So just do the best that you can. And now I'm gonna draw my box and whisker plot. Now the box and whisker plot goes above the data line. It doesn't go on that number line, it's gonna sit above it. So my minimum 18, I'm gonna put a dot, and my maximum 30, I'm gonna put a dot. Those are gonna be the ends of my whisker. The median is 25, which is right here. That's gonna be the middle of my box. And then my quartile 3 is 29, which is the end of my box. So from 29 to 24, or to 25, there's my median to quartile 3. There's the right side of my box. The left side of my box goes from 23 to 25, so right about here, and then I can connect my whisker. So when I look at this diagram, the whisker on the left is a lot longer than the whisker on the right. So it makes it look more like a skewed left, not a symmetric batch of data, right? It's not all centered symmetrically. It's getting pulled to the left because of that 18. And when you look at the numbers, 18 is way low compared to everything else. All the other numbers are mid-20s. There is a 22. There's two 22s. But everything else is pretty far from 18. So it makes sense that that 18 would pull the whisker way far to the left and it wouldn't be symmetrical. So the questions it asks, find and interpret the range and the interquartile range. Now the range is the largest number to the smallest number. And what it means by interpret is put it in context of the problem that you're doing. So this says that the ages of the members of a backpacking expedition, that's what these numbers represent. So when I find the range, I take the biggest number, 30, and I minus the smallest number, 18, and I get 12. So I would say that the difference between the oldest and the youngest person is 12 years. The difference between the oldest and youngest member is 12 years. So that's what it means by interpret, is explain what it means in real life, that number 12. Don't just tell me the range is 12. The difference between the biggest and the smallest is 12. We're putting it in context of what the data actually represents, okay? The interquartile range is similar, except you're only looking at the box. You're looking at the range of the box, not the entire shape. So in this case, my upper quartile is 29. My lower quartile is 23. So 29 minus 23 is 6. So that means that 50% of the people, remember each of these boxes represents 50% of the people. So I could say something like 50% of the members are between 29 and 23. Oh, I guess we're supposed to be using the range, huh? I probably shouldn't use the quartiles. So 50% of the members are within 6 years of each other's age, right? Of each other's age. So you're just explaining what that number means in the context of the question. You could say that 50% of the people, I guess we're still talking about range, huh? 50% of the people are between those two ages, so they're within 6 years of each other. You've got 25% that are older than 29 and 25% that are younger than 23, which is going to come up here a little bit later, right? So number 3 says describe the distribution. So the distribution is kind of the shape, all right? So when you look at this graph, this one's a little bit complicated to describe because the left whisker is longer than the right whisker, but the right box is longer than the left box. But when I look at this, it still looks like the skewed left picture, right? It looks like most of the data is above 25 instead of below 25. So you would say that the data is skewed left. Right? If it was centered, we would say it was symmetric, but it's skewed to the left. Okay, so here's another box and whisker plot. This one's already made for you. It wants you to analyze it, not create it. These are the lengths of songs played by a band in a rock concert. So it says find and interpret the range. So range is longest song minus shortest song. So 300 minus 160 equals 140 seconds. So to interpret that, now I need to say that answer, 140 seconds, but I need to put it in context of what this math problem is talking about. Well, we're talking about the lengths of songs. So the the longest song is 140 seconds longer than the shortest song, is one way that you could put it. You could also say there is a 140-second difference between the longest and shortest song. That's kind of saying the same thing using different words, right? Describe the distribution. When I look at this, the left box and the left whisker are a lot longer. So this is definitely skewed to the left. Find and interpret the interquartile range. So that's this value and this value. So I would do 280 minus 220, and that would give me 60. And remember, these are seconds. So what does that mean? That means that there's a couple of different ways that we can say this. We can say that 50% of the songs are within 60 seconds of each other's length. You could say that the third quartile song is 60 seconds longer than the first quartile song. I like using the box. 50% of the songs are within 60 seconds of each other's length. And you could even say the middle 50% of the songs. There's lots of different ways you can say it as long as you're putting it in context of the math, like the situation that the math is talking about, okay? Is the data more spread out below quartile 1 or above quartile 3? Well, we already described the distribution of the data, right? It's skewed left. So it's spread out more below quartile 1 because quartile 1 it goes from what, 160 to 220. So it's 60 seconds long or 60 seconds wide. Quartile 3 to the max is only 20 seconds wide. So the data is a lot more spread out below quartile 1. All right, well, let's analyze two box and whiskers side by side. So this says that these are the test scores of your class and your friend's class. So it looks like your class did better. Your friend's class, the data is a lot more spread out, isn't it? It says identify the shape of each distribution. We better start there. So your class scores are symmetrical, right? The left whisker and not your class. Your class scores are skewed left. Your class scores are skewed to the left. That left whisker is a lot longer than the right whisker. Your friend's class scores are symmetrical. Okay, which test scores are more spread out? So now we're looking at the length of the diagram. So your class goes from 100% to what, about 68%. Your friend's class goes from 60 to 100. So your friend's class's scores are more spread out since the boxes and whiskers are wider. Okay, let's look at a different situation. You've got Shop A that makes surfboards and Shop B that makes surfboard, and these are their prices of boards. So it looks like Shop A has a lot bigger variety of prices. Shop B, their boards are cheaper, they're lower in cost, and they're a lot more close together. The prices are a lot more close to each other. So it wants me to identify the shape So both of these are skewed to the right. Both shop A and B prices are skewed right. I know you guys don't like writing full sentences, but too bad, you're going to have to on these. And which shop's prices are more spread out? So shop A prices are spread from $300 to $900. So they are more spread out because shop B is only going from what, like $250 to $600. So shop A's diagram is a lot wider than shop B, so the prices are a lot more spread out. And that's kind of it today, guys. The math isn't super difficult. It's not too crazy. It does require you to analyze data a little bit, but the data you're analyzing is pretty easy to read, right? You're just looking at how far the data is spread out and where the data is grouped up. So homework, you've got a couple problems at the bottom of the first page that you just are drawing the box and whisker plot. And then the second page, it gives you box and whiskers and you're analyzing the situation. You need to be using full sentences to answer these questions. If you don't, you're not going to get credit for this assignment. So at the top, if you need to write a reminder, use full sentence answers. No shortcuts on this one. You got to explain your answers with a full sentence. All right, come see me if you need any help.